Okay, this is problem 618. I'm just gonna go on the fly again a little bit. I did a little bit of working on this and just to make sure I have the idea, but if I have to slow down a little bit, that's just because I'm still trying to think about the problem. So this problem is 618. So the number of claims per year from a particular auto insurance policy has a Poisson distribution with the mean of 1 and the probability function pk. So what I'm going to write here is that first of all they told us that pk is our probability function, and we see that k is there, so and the mean was 1, so we know we got this right here where k could be 0, 1, 2, and so on. Says and we'll just leave that there, we won't go any further. Based on the number of years of experience, the insurer decides to change the distribution. So we basically are having a transformation here, so that the new probability of zero claims is this. So this is the new one. The new one is that the probability will be 0.5, and the other probabilities will be the new one will be obviously anything higher, right? Which will be, obviously from k is greater than 1, right? So and are proportional to the old Poisson distribution according to this P of k star is equal to this. So let me write that here. P k, so the new one is proportional to the old one, P of k. And then it says obviously find the mean. Alright, of the new distribution. Okay? Not the old, but of course the new. Sounds simple. Alright, first thing we want to do is, we know that the total probability has to equal to 1, and if probability of the new one plus the subsequent ones from k is equal to 1 to infinity, right? These are the probabilities. Well, we know that this one is 0.5. So then this one right here must equal to 0.5 as well, right? Must be. And this right here is P of k star is equal to 0.5, the probability, right? The probability is 0.5. And that is still equal to, and we know this probability must be proportional to the old P of k. Alright, so this is where we have to totally understand what's happening here, and that we need to know this P of k, where k is greater than 1, right? We need to know that probability of the old. So the old one, I'm going to put old and make sure I bring this up so you guys can see. The old probability was 1, and obviously we had P naught plus subsequently this P is 1 to infinity of everything of old, right? Right. Well, The old one said at k is equal to 0, it would be e negative 1, and of course this would be a 0 here, k, and we have this over 1 plus this information here. And this information here, remember, is how we noted it as p of k. It is the old. It is what is old, not the new, because this is but of the old. Well, I'm just going to put a line here. Therefore, right, this new p of k, or probability of the old, is 1 minus e minus 1. There's the probability, right? And this is the number. We can actually evaluate that because there's no variable inside there, right? So 1 minus e minus 1 is 0.6321. Alright, so now we have the probability of the old when k was greater than 1. So now we can slap that in there. Let's go ahead and put pk star is equal to c times this probability, p of k, right? P of k of the old, and c, this is the 0.5 here as well. Make sure we know what we're doing here. The probability of the old, which was 0.634. Therefore, we solve for c. C is equal to 0.5 divided by 0.6321, and now we have a number. So what's 0.5 divided by that? 0.7909. Now, that wasn't what the question asked us, and I'm sorry I didn't show you all that. I gotta keep looking at the screen. The question is, what is the new mean? The new mean, right? And that's the expectation of the new. And the expectation of the new is, thank God we only have two probabilities here. We know when k is 0, we have a probability of 0.5. And then we have another probability, which will be c times the probability of k star. Well, we definitely know, and we can, right? Well, actually, it will be, the new one was actually just the new, sorry, times whatever k it was, and this is obviously k greater than 1, sorry. And then what we're going to do is, I'm going to do a little trick of just running the expectation through, right? This is 0, right? We don't forget about that. So remember, the new one is represented by this right here, which is c and p of k. But I'll do it correctly, which will be the, well, I won't even run that like that. It'll be c times e minus 1 k over k factorial for k is greater than 1, greater or equal to 1. Okay, and like I said, I would watch my screen, and I didn't do that. It's greater than 1. And what we see here is we can go ahead and bring this c out, which of course we know what c is, right? And we also can bring this e1 out, and then we get this funky little thing right here, right? And if we recognize that, that's the e raised to the 1, right? And then we know that c times e negative 1 to e1 is just e to the 0, which is 1, which is just leave us c, and our C was 0.709. And remember, we already did the expectation of K is equal to 0, and that just sort of got put away. So, like I said, I was a little confused still on this, but at least we found the answer. I'm trying to explain it the best way I understood it. So this will be option A on this problem. Good luck in your studies.